Welcome to Explore Labs. So this tutorial will be concentrating on Arduino with KiCAD. We wanted to do a tutorial where the board would be a little more complex than the first one, and it would have a good number of components or parts, and it would be useful and widely known in general. So the Arduino UNO, which has a fair mix of components, it has SMD ICs, then you have a DIP IC and the breakout pins and a few passive components. It would be a good starting point with PCB design. So in this video we'll see what are the components or important blocks that the design needs, and we'll see the schematic right in the beginning so that when we draw we'll have less number of doubts. So to start with, Arduino uses AVR or a Atmel microcontroller. So it uses a Atmega 8328 or 168. This is a basic 28-pin microcontroller. We'll see the details in just a while. So it basically requires a microcontroller, so it could be any of the three. Now what the Arduino does basically is it provides a convenient way to interface analog and digital circuits. So basically it's a microcontroller board with analog and digital pins. So you have a few input output pins on one side and also some more pins on the other side. So you have some of them are analog and some of them are digital. To be precise, it has about 6 analog inputs and about 14 digital inputs. Out of the 14 digital input output pins, so it is both input and output when it comes to digital pins. So out of these 14, the 2 are RX and TX, which is receive and transmit for the serial communication. So these are the input output pins. Also you have a few power pins so that you could power up your external peripherals from the Arduino. Now Arduino UNO, it has gone through a lot of revisions, and it has used a lot of USB to serial converters. In this series we'll be using a USB to serial converter, which is CP2102, or this is simply a USB to serial converter. Now Arduino uses a USB to serial converter in order to burn the sketch or the hex file. It is also used to communicate with the PC. So any application in which you need data to be dumped on the PC, or the inputs are coming from a PC, you need a USB to serial converter. Now apart from all this, it requires a little bit of power supply circuit, and when you are first making an Arduino board, it needs to have something called as bootloader, because when we have an Arduino, every time we use USB to serial to program it. So inherently it uses a program called a bootloader to program itself. So, uh, the controller has a bootloader which needs to be burned for the first time, and for that we use in-circuit programmer, or it is simply called ICSP, in-circuit serial programmer. So this is needed just for the first time to burn the bootloader, or whenever you change a controller, uh, you need to burn the firmware or the bootloader for the first time. So these are the ICSP pins. So the block diagram view seems to be very easy, and we'll go ahead and see these sections one by one in just a while. So first off, let's look at the microcontroller. So this is a 28 pin microcontroller. It comes in different packages. So it could be a SMD, surface mount device, it could be dual inline package, or it could be some other package, but the Arduino uses a dual inline package, or the DIP. So as we had seen earlier, it gives out about 6 analog pins. So these are basically the analog inputs of the controller. So if you look here, port C1 to C5, so these are the analog inputs, 6 analog channels, and then we have about 14 digital inputs. So this is AD0 to AD7, so it's port D, complete 8 pins, and then we have port B, which is 0 to 5. So 6 and 7 are basically crystal, connected to external crystal, hence they are not used. So these are the 6 pins. So we have about 8 plus 6, which is about 14 digital pins. And you could also see that the 2 of the pins on port D, the port D0 and D1, they have alternate functions. They can be used as receive and transmit. So these pins are multiplexed. So likewise, among the analog pins PC4 and PC5, they are they are alternatively used for the I2C protocol, the data and the clock lines. So so this is about the controller. Now the basic difference between Atmega 8, 328 and 168 is in terms of amount of RAM that we have. So we can dwell on that stuff a little later. So this is basically about the microcontroller. So the minimum connections that are required for this would be, so it would basically require a crystal circuit. So Arduino takes about 16 megahertz, so this is maximum that this controller supports. So it works on crystal frequency of about 16 megahertz. So this is the crystal. Then the other essential part that is required is a reset circuit. So normally this is low on reset, that is whenever we give a low signal, the controller resets. So it is usually tied to VCC. So whenever a switch is pressed, it gets reset. Now this could also be done using the reset could also be done from the software, and for that it uses a DTR signal. So DTR, again, it comes from the USB to serial converter. So this resets the controller as well. Now so this is basic. These are the basic connections that are required, and on the right hand side you see that these are the additional connections. So these are digital pins 8 to 12, and these are digital pins 0 to 7 and 8 to 13. So these are about 14 digital pins and 6 analog pins as we had seen earlier. So these are digital and these are analog pins. So and also you see a LED connected to pin 8. So this will find in most of the Arduino boards. This is a test LED. You can do a LED blinking program with it. Now the only remaining part that you see here is on the top. You see ICSP connector. So this is basically to program or to burn the firmware, or even to program the controller for the first time. So let's see the ICSP pins. So this is the breakout for ICSP. So you see a 6-pin header, and the pins are master in, slave out, then the serial clock, master out, slave in, reset, VCC, and ground. So these are put up in the same fashion which is shown here. So this is a 6-pin header for the ICSP. So the basic required for the microcontroller are: first it requires power, so then it requires a crystal circuit. So this is about 16 megahertz for the Arduino. And then to burn the bootloader for the first time, we require ICSP connector, and it could also be reset using the software, and the others are simply the other pins are simply taken out as digital and analog breakouts. So this is about the controller. Next up we'll see the USB to serial converter. So as you have seen, it gives a DTR pin for software reset, and it gives a label on RX and TX, which means it can be used to serially communicate with the microcontroller. So let's look at the USB to serial converter that we have here. Now so basically what it does is it is a converter. So it receives 4 signals from the computer. One is the VCC and the other is ground, and you have a D plus and a D minus differential data input pins, and what it outputs is a complete serial port protocol. But out of that we just use RX and TX plus the DTR to reset the controller for a soft reset. We also use one more pin out of this which gives a 3.3 volts output that could be used to power a 3.3 volts low current peripheral. So this is about the USB to serial that we have on the block. So we have seen the microcontroller, and then the USB to serial, and the IO pins, as well as the ICSP connector. So power supply, it's a fairly simple power supply. It just regulates and gives a 5-volt output. So this is the basic power supply. You have a LED for the power supply as well to indicate the status, and you have a jumper here which connects either the 5-volt coming out of the external power supply or the USB 5 volts to the main microcontroller board. So if it is set between 1 and 2, so the board is powered from USB, and if the jumper is between 2 and 3, it is powered from the external power supply. So you have a power jumper. So if it is between 1 and 2, it is powered from the USB, Yes, and this is the uh, schematic for the USB to serial converter. So it simply has a USB connected on one end, and it gives transmit, receive, and the reset signals for the microcontroller. Now, what you could have observed is the labels uh, which show the pin connections. So we'll discuss all this in detail when we actually go ahead and put up the schematic for the Arduino. Thanks for watching.